Why do things fall? Like everyone else, I was told as a child that no one had properly answered that question until an apple unfortunately fell on the brilliant head of Sir Isaac Newton in the 17th century. The explanation is known all too well, given that it is repeatedly told to us from an early age. Why do things rise? I was not academically introduced to the man who answered that question until much later in life. His name was Archimedes, and he answered why things rise close to 300 years BC. The Archimedes principle is an extremely essential concept for more applications than you can imagine. The applications of this concept can range from estimating the composition of metal alloys to even lighter-than-air flight. A critical thinker should be perplexed by the fact that the answers to those two very similar questions are nearly 2,000 years apart. History seems to be the most unreliable of sources. I always found it very difficult to believe that the answer to those two very similar questions is not one and the same. I believe that Archimedes' work has been corrupted over the years, just like this work will inevitably be corrupted also. I believe Archimedes also answered the question of why things fall nearly 250 years BC, but most of his work has been lost or changed, probably during the burning of Alexandria. Regardless of whether or not he answered that question, the fact is I do in this video. I have successfully engineered the perfect answer to why things fall and rise, based largely on Archimedes' remaining works and my advanced understanding of physics, chemistry, and mathematics. I can confidently say that Sir Isaac Newton was so incredibly wrong on his answer to why things fall that I can only think of one word, and that is fraud. I hope that after watching this video you can come to the same conclusion. Archimedes, when asked why things rise, he would simply answer, density. For that is the correct answer to that question. The Archimedes principle is that which governs the motion of helium balloons, hot air balloons, submarines, etc. The principle states that the upward force of an object immersed in a fluid is equal to that of the weight of the fluid it displaces. Simply put, if an object is less dense than the medium it is in, it will rise. The force at which it will rise is mathematically expressed as the following. For a fully submerged object, for example humans, or any other physical object in air, the amount of volume the object displaces is equal to the volume of the object. V displacement equals V object. Also, floating objects are partially submerged, and therefore the resultant force is practically zero at floating rest. The previous explanation has been good enough for everybody so far, kids and academics alike. This explanation of why things rise being solely based on the density of the object, and the density of the medium it is in, has always been sufficient for everyone. Yet, when asked why things fall, Isaac Newton came up with a much more elaborate answer, one that required the assumption of the mass of the earth, and the creation of a constant which conveniently cannot be measured in a lab, and can only be measured at the most massive of scales, the cosmic scale, rendering the constant as purely theoretical and impossible to measure on a repeatable laboratory scale as science has always demanded. In a way, Isaac Newton was a pioneer in turning science into the faith-based phenomenon that it is now. Newton was the first to come up with theories that necessitated having faith in him and could not simply be tested by anybody. It is a common misconception that Isaac Newton is credited with finding g equals 9.81 meters per second squared. The truth is, long before the times of Newton, people knew about the fall rate of objects. That is why the constant g is included on the formula for the Archimedes principle, which was a known concept thousands of years before Newton. Thanks to the knowledge of the fall rate of solid objects, which is easily observable, humans have been able to build infrastructure such as cathedrals, bridges, aqueducts, and other infrastructure for thousands of years. The study of static forces and dynamic forces is much older than the times of Isaac Newton. What Isaac Newton is truly credited with discovering is the reason as to why things fall, for which he came up with the most intricate and peculiar of explanations. He said that matter attracts matter, but only if matter is heavy enough to be significant. Basically, he said that unlike your everyday objects, the Earth is the only object big enough within our range to affect us in any noticeable manner. He invented, fabricated, and imagined the following equation and constant in much the same manner that J.K. Rowling dreamt up the wizarding world of Harry Potter. F equals G, m1, m2 over r squared. He quite literally manufactured the G constant, and assumed the mass of the Earth, which still today is not proven, in order to get a G equals 9.81 meters per second squared equals G times the mass of the Earth over r squared, where r equals the radii of the Earth. This sort of science can only be compared to that of science fiction and fantasy writers. The truth is, the only factor which governs the vertical motion of matter is density. Both Newton and Archimedes think of mass wrongly, and not at all as it truly behaves in nature. We have often been taught to think of density as mass over volume. Although this is mathematically correct, the proper way to express the relationship between density, volume, and mass is the following. Expressing mass in this way, the truth becomes clearer, that mass is a variable dependent on the volume of an object. The true constant in an element or compound is density. Expressing mass in this way, the truth becomes clearer, that mass is a variable dependent on the volume of an object. The true constant in an element or compound is density. In other words, if we were observing and plotting the mass of a 1 meter cubed sphere, we would integrate its density over its volume and plot the mass as we go from the center of the sphere, which is at 0% volume integration, to the outer shell of the sphere, which is at 100% volume integration. Mass would be on the left axis, y-axis, and volume on the right axis, x-axis. Both would change, but the density of the object will be the slope of the curve and will remain constant, if the sphere is made out of a uniform material. For example, assuming a 1 meter cubed water sphere, it would look a bit like the following graph. The slope would equal the density, which is the only thing that truly remains constant. Understanding this statement is crucial to fully understanding how matter behaves, mainly because how matter behaves in a vertical direction is solely dictated by the density value of the object and the density value of the medium it is in, nothing else. Density is the only value constant in every element or stable chemical compound, meaning, under the same conditions, a single hydrogen molecule has the same density as a balloon holding 1,000,000 hydrogen molecules, but they do not have the same mass, nor volume, yet they both rise in air. The law of matter. If the object is denser than the medium it is in, it will fall. If the object is less dense than the medium it is in, it will rise. In this video, I will prove without room for doubt that what we think of as the force of gravity and buoyancy force are actually one single force. A density force is the name of the force that determines and dictates the vertical motion of any physical object at free fall. This force governs the vertical interaction between different forms of matter, and the direction of the force is solely dictated by the difference in density between the object and the surrounding medium. The resultant vertical force of an object at free fall is what I call the force of density, and is written as such. Where V equals the volume of the object, G equals 9.81 meters per second squared, Pm equals the density of the medium, and Po equals the density of the object. Equation 1 is not only mathematically true and applicable to real life, but also the direction is self-determinant. If the density value of the object is greater than the density value of the medium it is in, the term inside the brackets will be negative, and if the density value of the object is lesser than the density value of the medium it is in, the term inside the bracket will be positive. If the difference between the densities is negative, then the value of the resultant force will be a negative term, indicating the direction of the force is downwards. This is consistent with real-life observations, such as a stone in either air or water, where the stone density would be heavier than the medium, and thus it falls. If the difference between the densities is positive, then the resultant force will be also positive, indicating the direction of the force is upwards. This is also consistent with real-life observation, such as a helium balloon in either air or water, where the helium balloon is much lighter than air, mostly nitrogen, and thus it rises. Therefore, using this formula is not just the proper mathematical description of the vertical force experienced by matter, but it is also a more convenient method than the traditional method, which unnecessarily separates the force of density into two forces, the force of buoyancy and the force of gravity. Equation 1 is just as accurate as the traditional method, because it is mathematically equivalent to the traditional method, but simplified, and displayed in the matter in which it should be displayed. The following is the mathematical proof of their equivalency. The traditional method equation for an object at free fall is the following. Assuming up is positive and down is negative, Fr equals the resultant force. But we know that the volume displaced for a fully immersed object is V displaced equals V object. Similarly, we also know it to be true that the mass of the object is equal to. Therefore, we substitute into the equation and we get, which by grouping like terms equals equation 1. Similarly, equation 1 can be simplified further to obtain only the acceleration of the observed object, and this is how it is obtained. This equation will be called equation 2, and it is instrumental in the experiments needed to prove that the constant g is indeed the constant fall rate of matter in empty space, and not the constant acceleration due to the gravitational pull of the Earth, as Isaac Newton claimed. Equation 2 shows that the rate and direction at which a material either rises or falls is solely dependent on a difference between the density of the medium and the density of the object. Therefore, answering the question asked on the title page, according to equation 2, the rate at which a material rises or falls is independent of its volume or the amount of material, mass, meaning that helium rises at a certain rate in water and another in air, whether it is a single helium atom or whether it is millions of helium atoms occupying the shape of a balloon. In other words, matter rises or falls by virtue of its own innate physical properties, and not because of dimensions such as volume, radius, or overall mass, like Newton proposed. A simple plug-in experiment into equation 2 shows that it is true for all observable phenomena, such as an air balloon in the air, a helium balloon in the air, rocks in the air, lead in water, etc. It also explains why feathers and exhaled air balloons do not fall as quickly as a stone, given they are much closer in density to the air than a stone. A stone, since it is far denser than air, it falls at such a rate as to nearly render the density of the medium, air, negligible, and thus a stone falls at a rate relatively close to g equals 9.81 meters per second squared. On the other hand, an exhaled air balloon, given that it is mostly air with a higher CO2 content, falls slowly in air because it is only a little bit denser as a whole than the air around it. Humans are very close in density to water, thus they make a great example of my principle. Most humans sink relatively slow in water, but some babies and people with relatively high body fat ratios can float with relative ease. There are also floating techniques that can help a human float in water. The material humans are made of sinks slowly in water, and the center of mass for that material is at the belly button, which is where we experience the sinking. However, when we take lots of air into our lungs change density and become less dense than the water, and thus start pulling us up. There are floating techniques that help us align the pull from our belly button with the pull of our lungs and help us float. Other techniques help us float by grouping the pulls close together and using a slight kicking motion to keep our legs afloat. Similarly, you may have noticed that if we take in a lot of air into our lungs, descending becomes very difficult, but if we purposely exhale all the air in our lungs, we start to descend quite rapidly. The most misunderstood yet most important experiment on this subject is the Bryan-Cox experiment. It is an experiment where he drops a bowling ball and a feather from the same height and records it using a high-speed camera, slow motion capture. As repeatable observed phenomena shows, in air, the bowling ball falls much faster than the feather, but in a vacuum, as demonstrated by the experiment, they fall at the same rate. The biggest fallacy of the experiment is the assumption that Brian Cox makes. He believes that this experiment proves gravity because since the air is removed and the medium is now a vacuum, empty space, thus there is no resistance from the medium, and thus no buoyancy force, and the only observable force left should be gravity, and thus they both fall at the same rate. But, and a big but, if you notice my formulas can precisely and mathematically explain without failure the observable phenomena in the vacuum, because in a vacuum, the medium is nothing. The medium is empty space, and the density of empty space is zero. Then think of matter as occupied space. If we plug in a density of 0 for the medium into equation 2, the equation becomes the following mathematical limit question. Therefore, density cancels out, and this means that according to the math of equation 2, all matter falls at the constant acceleration g in empty space regardless of the object's density. The limit evaluations show us that as the density of the medium approaches 0 in a vacuum, then the observed object's rate of fall approaches g equals 9.81 meters per second squared. Therefore, since both the feather and the bowling ball are infinitely denser than empty space, which has a density of 0, then they both fall at the constant fall rate of matter in empty space. Matter is infinitely denser than empty space. Therefore, the vacuum experiment is proving without a doubt that g equals 9.81 meters per second squared is the constant fall rate of matter in empty space, as proven by the equal fall rate of a feather and bowling ball in empty space. There are two ways to obtain the value of the constant g according to equation 2. One is using multiple runs of an object or various objects which densities are known, and observing and recording their fall rate or rising rate in different mediums which densities are also known. In the experiment, the observed acceleration and direction must be recorded, and by plugging the observed acceleration into a y-axis and the densities into the x-axis, then simple data analysis can be used to obtain the constant g, which would be the only value constant throughout all the experiments with different densities. The other way to obtain the constant g is the Brian Cox's vacuum experiment, given that by making the medium in the experiment empty space, then the constant g becomes the observed acceleration. Thank you, Brian Cox. I would have never secured the funds for such an experiment, but I have your blessed naive ignorance to thank for proving my equations to be mathematically true with your experiment. In conclusion, here is where I ask the reader to reconsider their previous beliefs. I do not know why something so simple has been purposely hidden in plain sight for all these years, but the fact remains that it has. The world we live in has rules, and the rule that determines whether an object falls or rises is not the size of the earth, or how much it weighs. It is, clearly, the density of the object and the density of the medium it is in, nothing more. I sometimes wonder if the apple had not fallen on Newton's head, and instead had fallen in a bucket of water, if he would have then figured out the reason why the apple truly fell, and then never would have come up with such an absurd theory such as the theory of gravity. Maybe he would have wondered how the apple's gravity was magically turned off as soon as it hit the water, given that apples float and all. Maybe then he would have noticed that what made the apple fall was not gravity, but the density differential between the air and the apple, nothing else.